Here's a flow-proof example for section 5.2. You'll want to get this in your notes. So triangle inequality proof, take a minute and sketch this. We've got triangle PQR, and it almost looks like QS is a median. Let's say that we've got angles 1, 2, and 3, and we are given that segment length PQ is longer than QR, and our task will be to prove that PQ is greater than QS. So the key with this one, or with this proof, is to ask yourself, how many triangles are we dealing with? Well, we have 3 triangles. We've got the entire shape, the green there. We've got that blue triangle off to the right, and then this red triangle. So let's call it PQR, QSR, and PQS. The reason that's important is, take a look at our prove statement. We want to prove that length PQ is longer than QS. Well, PQ and QS are both segment lengths in the red triangle, in triangle PQS. So we're going to want to say something about either the lengths of the sides or the angles in that triangle. So that'll be our task, and in order to get there, we need to first look at the given statement. So given says PQ is longer than QR, and as a result, the angles opposite those sides are going to be also unequal in the same order. So 2 must be greater than 3. Next, take a look at that blue triangle. The blue triangle has an exterior angle, angle 1. And remember the exterior angle inequality says that angle 1 must be greater than angle 2. So in the blue triangle, we can ascertain that 1 is greater than 2. From the green triangle, we know that 2 must be greater than 3. So if 1 is bigger than 2 and 2 is bigger than 3, then 1 is bigger than 3. And 1 and 3 are both angles in that red triangle. All right, so let's write this proof out. First, we know from the green triangle, if PQ is longer than QR, then angle 2 must be greater than angle 3. Next, from the blue triangle, angle 1 is an exterior angle, and as a result, it has to be greater than its remote interior angles. So then, using the transitive property, we can prove that 1 must be greater than 3. Now, if 1 is greater than 3, then the side opposite angle 1 must be longer than the side opposite angle 3. And so there we have it. We've proven that PQ is greater than QS because in one triangle, if the angles are not equal, then the sides opposite those angles must also be not equal in the same order.